Hello, hello. Okay. Hello. Good evening, students. Today we are going to discuss real numbers. This is the very first chapter. The very first chapter we are going to start with real numbers. And for your new session, for your boards in your next year, real numbers are, although the CBSE has introduced new changes in the class 9 textbook, but for your class 10, no major changes are done in the book. Whatever book was followed the last year, the same book will be followed more or less this year also. No fundamental changes are done. The book will be changed. There will be a major change in the class 10 textbook next year, but that does not concern you. ঠিক আছে, সেইটো তোমালোকক কনচাৰ্ণ নকৰে। কেলে? কাৰণ সেইখিনি হ'ব অহা বছৰ। তোমালোকে এই বছৰে দিবা CBSE ক্লাছ 10ৰ পৰীক্ষাখিনি, হয়নে? চ' সেইটো তোমালোকৰ কাৰণে ইমান কনচাৰ্ণ নহয়। গুড ইভিনিং। ঠিক আছে, so whatever changes are there, whatever changes whatever changes are done in the class, the changes are done in the class 9 textbook. Class 9 or maths খনত তোমাৰ ভালেখিনি চেঞ্জ কৰা হৈছে। Okay, in the class 9 maths there are major changes done in the textbook. But in the class 10 textbook, of CBSE, nothing much has changed. Nothing much has changed. Whatever was followed the last year, the same book will be followed this year also. If you have not purchased the book till now, তোমালোকে NCERT website গৈ কেনে কিতাপখনৰ PDF টো ডাউনলোড কৰি লোৱা at least. Okay, just go to the website of NCERT. You just type NCERT textbook, you will get the website, and তোমালোকে maths class 10 textbook খন PDF হিচাপে ডাউনলোড কৰি লোৱা and just start studying. Okay, so today we are going to discuss the very first chapter, real numbers. We are going to discuss what real numbers are. Okay. Now before I start what real numbers are, before I begin what real numbers are, why is the chapter name real number? See, every word has a synonym. পৰ্যায়বাচী শব্দ থাকে, হয়নে? সমাৰ্থক শব্দ থাকে. Every word has a synonym, then every word will also have an antonym also. If there are real numbers, do you think there exist non-real numbers? That is my first question to you. See, let us see, whoever is watching the video on YouTube live, let's play a game. If you think, my question to you is, our chapter name is real numbers, so that is okay. If anyone thinks that there are numbers called non-real numbers, then you give me any flower emoji. Let's see. Whoever thinks that there exist non-real numbers, give me any flower emoji. Let's see. Let's play a game. Whoever thinks there are numbers called non-real numbers, then just give me a flower emoji. Do you think, see, your chapter is named real numbers. Why do you think the chapter is named real numbers? Why not name it, say, any other chapter? If real numbers are there numbers called non-real numbers? Do you think yes or no? Yes or no? So the answer to the question is yes. There are numbers called non-real numbers. There are numbers called non-real numbers also. But that is not in our discussion. That you will get in class 11. Those numbers are called complex numbers. Those numbers are called complex numbers. Now, why they are called complex numbers? Let us discuss that first. Okay. Why real numbers? What exactly are real numbers? See, whenever we are speaking on anything, whenever we say about natural numbers, whole numbers, integers, negative numbers, rational numbers, irrational numbers, everything comes under the box of real numbers. What did I say? I said all the natural numbers, all the whole numbers, all the integers, positive and negative, all the rational numbers, all the rational numbers, all the irrational numbers, all of this, all of this comes under real numbers. Everything is included in real numbers. Okay. Sir, secondary lecture भी ISI channel पे the second lecture will not come on this channel. For that you have to go purchase the course on our app. This is the first lecture which is free. If you want to go to in depth, if you तुमको अगर पूरा in depth में पूरा course चाहिए where all the chapters will be discussed exercise by exercise, that will be available on our app. That is available on our app, which is our X School app. तो वहाँ पे तुमको सब कुछ मिल जाएगा. Every course is available. The entire maths course I will be teaching for the entire year, where I will be discussing all things A to Z. CBSE का तुम्हारा PYQ का लेके competency based question लेके case study, everything, sample paper जब आएगा official, everything will be discussed on our app. On our YouTube channel, things will be there, but on a restricted way. Okay. Okay. Coming back. See, what did I say? Natural number, whole number, integer, positive, negative, rational number, irrational number, everything comes under the box of real numbers. Then what are non-real numbers? I'll be giving you a very, very small example. See, if I say x square minus 1 equals to 0, this means that x square equals to 1. This means x square equals to 1. Yes or no? What is the value of x? What is the value of x? See, you will study this. You will study these things in chapter 4 in quadratic equations. Then x is said to be something as square root of 1. Yes. Even this is a real number. But can you tell me what is the square root? What is the square root of say minus 3? Can you find the square root of a negative number? Can you find the square root of a negative number? You cannot. And that is where exactly are non-real numbers. Non-real numbers are those which does not fall under our box of real numbers, and those are exactly these numbers. Numbers like square root of negative numbers. You cannot find the square root of a negative number. For that we have to expand our horizon. We have to go beyond real numbers, and going beyond real numbers is where non-real numbers are there. Yes. So for real numbers we are going to discuss. So for real numbers, maths is not entirely numbers. For maths, we try to understand the very behavior of numbers. We are trying to understand the very psychology of numbers. Yes, we are going from negative infinity to infinity. We are on a journey from here to go on a search of how numbers are behaving on a scale from minus infinity to infinity. We are trying to understand the world through numbers, through the lens of maths. That is the very aim of mathematics. It is not simply numbers. कि तुमको कैलकुलेशन आ गया तो यू आर गुड इन मैथ्स, तो उस हिसाब से तो हर कोई दुकानदार मैथमेटिशियन हो गया. तुम सब्जी वाला के पास जाओगे, तुम सब्जी लोगे, 1 kg आलू, 2 kg प्याज लिया, ये लिया, वो लिया, तुम हिसाब करने बैठोगे, दुकानदार तुमसे पहले बोलेगा कि 90 रुपये हो गए. और तुम अभी सोचोगे मैं तो क्लास 12 में मेरा तो मैथ्स लिया था, मुझसे ही नहीं हुआ, इसका इतना कैसे हो गया. तो कैलकुलेशन इज नॉट मैथ्स. इफ समवन टेल्स यू तुम भी मैथ्स में इतना अच्छे हो, कैलकुलेशन में इतना स्लो क्यों, यू टेल देम कैलकुलेशन इज नॉट मैथमेटिक्स. मैथमेटिक्स इज समथिंग एल्स. ओके. Okay, so now in real numbers we got what we are going to study. We are going to study the very foundation, the very behavior of natural number, whole number, integer, positive and negative integers, rational number, irrational number. All of this we are going to discuss in this chapter called real numbers. Okay, and in that thing, the very first theorem. See, in your class 10 textbook you will not get not many theorems. Very few theorems you will get. And the very first chapter has the first theorem. The very first theorem you will get is something called the fundamental theorem of arithmetic. बहुत लंबा चौड़ा नाम दिखता होगा, वैसे कुछ है नहीं. You read the statement of the theorem. You read the statement of this theorem. ओके, स्टेटमेंट पढ़ लिया, कुछ समझ में आया? इतना लंबा चौड़ा स्टेटमेंट है. डिड यू अंडरस्टैंड एनीथिंग? व्हाट इज द स्टेटमेंट सेइंग कि एवरी कॉम्पोजिट नंबर. पहली बात तो ये कि कॉम्पोजिट नंबर क्या होता है भाई, आएंगे उसमें भी आएंगे. व्हाट इज इट सेइंग कि every composite number can be express is nothing but factorize. जैसे you have studied prime factorization in your earlier classes, that is the same thing only, as a product of primes. We are speaking about prime factorization only, nothing else. And this factorization is unique apart from the order in which the prime factor occurs. Okay, now first of all, what is a complex number? What is a composite number? A composite number क्या होता है भाई? First of all, what is a prime number? Prime numbers are those numbers which are not divisible by, which are only divisible by 1 and the number itself. Just like 11. Yes, 11 is only divisible by 11 and 1. So that is why 11 is a prime number. Again, that is why 11 is a prime number. So those numbers which are divisible by the number itself and 1 are prime. And those numbers which are not prime, I would say, we call them composite numbers. But the proper definition is that composite numbers are those numbers. Composite number वो वाले number है जिनको 1 or itself, meaning the factors are more than 2. Any number is composite whose factors are more than 2. Let me take a very simple example. I will take a very simple example and you will understand. Suppose I take the number 18. Now if you prime factorize 18, कैसे करते थे? 2 लिया, ये हो गया 9, ये हो गया 3, ये हो गया 3, यहाँ 1. What is prime factorization? Prime factorization is that you divide the number, you keep on dividing the number by a prime number until and unless you reach 1. Yes, so 18 can be written as 2 to the power 1 into 3 square. Yes, so 18 can be written in this way. Now why is 18 a prime number? No. Why? Because the factors of 18 are more than 2. 18, if a number is divisible by more than 2 factors, we say that it is a composite number. Yes, here if you see 18 is divisible by 18, 18 is divisible by 1, 18 is also divisible by 2, 18 is also divisible by 3, 18 is also divisible by 3 square, which is 9. Yes, so 18 has so many factors. So those numbers are composite whose factors or numbers which can divide that particular number are more than 2. But if a particular number is only divisible by exactly 2 numbers and those 2 numbers are nobody but the number itself and 1, then we say that that number is prime. If a number is not prime, it can be categorized as a composite number. Okay, अभी यहाँ पे क्या बोल रहा है? यहाँ पे बोल रहा है कि here I can write this as 2 into 9. Yes, what is saying? Every composite number can be expressed or factorized as a product of primes. Again, here haven't we done the same thing only? Here 2 is a prime number, 3 is a prime number. We have expressed 18 as a product of primes. I have expressed 18 as a product of primes, and this factorization is unique. Unique मतलब 18 का prime 18. If you prime factorize 18, then you will get only this thing. Apart from the order in which the prime factors occur. मतलब तुम 2 into 3 square लिखो या 3 square into 2 लिखो, बात तो सेम ही है. There is no other prime factorization for 18 other than this 2. Here if you change the order of multiplication, 2 into 3 and 3 into 2 is the same thing. Again, so इतना लंबा चौड़ा स्टेटमेंट का मीनिंग यही है बस कि कोई भी composite number ले लो, you take any composite number can be factorized as a product of primes, and that factorization is unique. यह factorization unique है apart from the order. 2 into 3 लिखो, 3 into 2 लिखो, बात तो वही है, लेकिन इसके अलावा तुमको और कोई प्राइम फैक्टराइजेशन मिलेगा नहीं. So that is what the fundamental theorem of arithmetic says. Clear? So that is exactly the fundamental theorem of arithmetic. Any doubt till here? If you have any doubt, you can ask in the comments. Do you have any doubt? If you have any doubt, you can ask. Okay. So that is the first thing that you have to, that we are supposed, that is in the chapter, the fundamental theorem of arithmetic. Then after that, the chapter goes on to our basics of HCF and LCM. The chapter, the very last part of the chapter discusses on HCF and LCM. Okay. Now what is HCF? What was HCF? HCF is nothing but the product of the smallest power. Product of the smallest power of each of the common prime factor in the numbers. Okay. And what is LCM? LCM is simply the product of the greatest power of each prime factor involved in the numbers. Okay. Well, ultimately you know how to calculate HCF and LCM. Here this is given in a much more compact way. You are given the definition here. Okay. So here you are given in a much more compact way. So I think the only new thing that you will learn is this particular formula. HCF into LCM. HCF of any two numbers into LCM of any two numbers is equals to the product of the two numbers. But this is asked in MCQs that those two numbers, those A and B, have to be positive numbers. This formula is not valid. This formula is not valid if A and B are negative numbers. Okay. This formula is not correct if A and B are negative. This formula is only valid if A and B both are positive numbers. So this part of the formula, this what to say, this condition is asked in MCQs. Okay, this condition is asked in MCQs. Okay, okay. Any doubt till here? Any doubt? Those who are watching the video, any doubt? Okay, so that is it. Then HCF, LCM we are going to discuss. Then at the very end, the chapter discusses the irrationality. The chapter discusses the irrationality of root 2, root 3, root 5 and all of these things. Okay, and one more theorem you will get, another theorem you will get on this part which is the second theorem. which is the second theorem we will get in the chapter. Key, if any number, if say p, if p divides a, if p divides a, then p also divides a square. So this statement, this theorem we will get in later part of the chapter. Okay. This particular thing, the converse part also you will get, actually you will get the converse part of this, that this is also conversely, converse part is actually, the converse part is actually in the book. कि अगर p, if p divides a square, actually this is the theorem. If p divides a square, then p divides a. What is p here? Your p is a prime number. Your p is a prime number. This theorem, this theorem we are going to use in proving then numbers like root 2, root 3, root 5, any number, any prime number under the square root, any prime number under the square root is irrational. And the proof of this, in the proof of this particular theorem, this part of the theorem is used. Okay, so that is in the last part of the chapter. In the very last part of the chapter, we discussed the numbers like, the numbers like root 2, root 3, root 5, root 7, root 11, root 13, root 17, root 23. If you see, every time I am using a prime number under the square root. So any prime number under the square root is irrational, and that part can be proved using this very theorem. Okay, so that is discussed in the very last part of the chapter. For now, let us begin the very first exercise. Now we have discussed, what we have discussed till now? We have discussed the fundamental theorem of arithmetic. Done. Then we have discussed on how to calculate HCF and LCM. We'll learn what this part was saying. What are these things? We'll learn as we do questions now. We'll be doing exercise questions now. When we'll be doing exercise questions, all of these things will be used. Okay, then things will be clear. What is this particular statement is saying? All of these things will be clear. How to use this particular formula also it will be clear. Then how the fundamental theorem of arithmetic is used. Now we'll do the questions of exercise 1.1. Then things will get clearer. Up till now, if you have any doubt, you can ask. Now I am going to begin the exercise. Okay. Okay. So the very first question. Okay. So now we are asked, what are the prime factors? See, just easy questions. Let's see. We'll do. Okay. What is given? Express each number as a product of its prime factors. Meaning you are told nothing but to simply just prime factorize. Take 140. 140 you simply prime factorize. क्या होगा? ये 70 होगा. Again divide by 2. You will get 35. Divide by 5. You will get 7. 7 you do. You will get 1. You have reached 1. Your काम is over. So therefore 140 I can write as 2 there are 2. So this is 2 square into 5 into 7. Okay. So we have written 140 as a product 140 as a product of primes. Now, what does the fundamental theorem of arithmetic say? The fundamental theorem of arithmetic says that any composite number 140 is a composite number. 140 is a composite number. Why? Because 140 is a composite number because 140 is divisible by 2 also. 140 is divisible by 5 also. 140 is divisible by 7 also. Again, if a number is divisible by more than 2 factors, then that number is composite. Done. And what does the fundamental theorem of arithmetic say? The fundamental theorem of arithmetic says that every composite number can be expressed as a product of primes. And exactly we did exactly that only. We have expressed 140, which is a composite number, as a product of primes. So here this is simply an application of fundamental theorem of arithmetic. This is how the fundamental theorem of arithmetic is applicable. Clear? Any doubt? Any doubt? यहाँ तक कुछ doubt? Similarly, let us go for 156. Similarly, simply prime factorize 156. Here if you 2, it will be 78. And just divide, this will be 30, 39. If we divide by 13, this will be 13, 13, 1, done. So therefore 156 I can write as 2 square into 13 square. Then it has been expressed as a product of primes, which is nothing but your application of fundamental theorem of arithmetic. Yes. Yes. Similarly goes for these two numbers also. Here what you have to do? All of this. In all of this, you simply have to prime factorize it first. First of all, prime factorize. Then same process. Same process. Okay. I hope it is clear. We go to the next question now. Okay. What is given? Find the LCM. We are told to find the LCM and HCF of the following pair of integers and verify. We are told to verify that LCM and HCF equals to product of the two numbers. Okay. Let's see. Let's do the first one. Let's do the first one, then we'll be able. See, we are doing exercise 1.1. Okay, I hope it is clear. We are doing exercise 1.1. Okay, see, if you see the very first number, we are told 26. 26 can be written as 2 into 13. So there is no other prime factorization for this. Similarly, 91 can be written as, I think 91 can be written as 13 into 7. So 91 can be written as 7 into 13. Done. So we have prime factorized. Again, 26 and 91 we have prime factorized. 26 can be written as 2 into 13. 91 can be written as 7 into 13. So factorization has been done. So the fundamental theorem of arithmetic is already applicable. Okay. So that part we have done. Now what is left is for us to find LCM and HCF. Now what is the HCF? What is the HCF of 26 and 91? If you look back at the very definition, what did the definition say? The HCF of any two numbers. The HCF of any two numbers is the product of the smallest power of each of the common prime factor in the numbers. Product of the smallest power, but of the common prime factor. If you see, what is the common prime factor here? What is the common prime factor here? Okay. Okay. So what is the common prime factor here? If you see 13, 13 is here, 13 is here also. So 13 is the 13 here is the common factor. Again, and you are told your HCF is nothing. Your HCF is nothing but the smallest power of the common factor involved. First of all, your common factor is 13. What is the smallest power of 13 in both these numbers? 13 to the power 1 only. So your HCF is nothing but 13. Your HCF is nothing but 13. Okay. Then LCM. What is your LCM? 26, 91. What is LCM? What did our definition of LCM say? Our definition of LCM said is the product of the greatest power of each prime factor involved in the numbers. The greatest power. Here it is the smallest power. Here it is the smallest power of the common factor. Here it is the greatest power of each prime number, of each prime factor involved in the numbers. Meaning is very simple. Meaning is very simple. Here if you see, what are the prime numbers involved here? The prime numbers involved here are 2, 13, 7, 13. What is the greatest power of 2 in both these numbers? 2 only. Into. What is the greatest power of 13 in both these numbers? 13 only. What is the greatest power of 7 in both these numbers? 7 only. So LCM is this. It is a product of the greatest power. Greatest means the highest power of the primes involved in the prime factorization of both these numbers. Clear? So this comes out to be, I think, 91, 182, 182. Okay. Okay. Done. Now we have to verify whether LCM into HCF is equals to product of the numbers or not. What is the product of the numbers? What is the product of 26 and 91? This is nothing but 26 into 91, which comes out to be around 2366, which will come out to be around 2366. Similarly, LCM of 2691 into HCF of 2691 is nothing but your HCF we got as 13, LCM we got as 82, 182. So it is 182 into 13, and if you calculate it, you will get it as 2366 only. Yes. So both these numbers are equal. Both these numbers are equal. So hence this part is correct. This part is correct. Okay. Your LCM into HCF is equals to product of the numbers. Okay. Hence verified. We have verified this part. Hope it is clear. सर क्लास 9 का सेबा है ना? Yes, yes. Class 9 SEBA is there. Class 9 SEBA is there in this channel also. I have uploaded for now I have uploaded the syllabus, because there are some changes done in your class 9 textbook. Class 9 का textbook में बहुत सारे changes किए हैं इस बार, थोड़ा book में भी changes किए, तो नया वाला book खरीदना है. You have to buy for class 9. Buy the new SEBA book, because पुराना वाला book नहीं चलेगा अभी. ऐसा नहीं है कि सीनियर से लेके तुम दे दिए. Buy the new book, the full course, the entire SEBA course I will teach on our app. You can go there and see the course if you want. All the details are there on the app. You can go there, and here on our YouTube you will be giving only a few classes free, and after that all the classes will be there on our app. Okay. The details are given in the Telegram group also. You can join the Telegram group and do it. Okay. तो बाकी ये सब करने का भी सेम ही टेक्निक है. Okay. I am just giving a brief view of how to do these things. Okay. सेम वही करना है. इन ऑर्डर सी, फर्स्ट ऑफ ऑल यू हैव टू फाइंड द एचसीएफ एंड एलसीएम 510 एंड 92. क्या करना है, पहले प्राइम फैक्टराइज करो, प्राइम फैक्टराइज करके देखना है, एचसीएफ एलसीएम ढूंढना है, फिर ये वाला चीज को वेरीफाई करके देखना है. ओके, लेट अस डू वन मोर क्वेश्चन. कहाँ गया? ओके, what is given, find the HCF and LCM of the following integers by applying prime factorization method. अच्छा, देखते हैं. First of all, let's do number one. What is the prime factorization of 12? 12 I can write as 2 into 3, 6, 6 into 2, 12. I can write as 2 into 3 into 2. हो गया. 15 I can write as not 2. 15 I can write as 3 into 5. Done. 21 I can write as 3 into 7. हो गया. अभी अभी see, these are the all of these things, these are the prime factorization. What I have done is simply prime factorization, nothing else. प्राइम फैक्टराइज किया है बस, और कुछ नहीं किया. प्राइम फैक्टराइज कर लिया है कि नहीं? प्राइम फैक्टराइज करना भूल गए होगे तो जस्ट ब्रीफली मैं दिखा देता हूँ. 2 है, ये 6 है, ये फिर से 2 करो, ये 3 निकलेगा. हो गया 1. सेम थिंग 2 into 2 into 3, and written 2 into 3 into 2. So prime factorization is nothing but you have to divide this particular number by a prime number until तुम 1 पे नहीं पहुंच जाओ. Okay, done. Now we have to find the HCF. So what is the HCF of 12, 15 and 21? First of all, HCF. What is the very full form of HCF? HCF का full form क्या है? In the very full form of HCF, you will get the answer. This is highest common factor. है कि नहीं? पहले राइट से लेफ्ट, पहले कॉमन फैक्टर ढूंढो. In all these numbers, in the prime factorization of 12, 15, 21, what is the common factor involved? If you see, the common factor involved is 3. Here also I have 3. Here also I have 3. Here also I have 3. छोटे क्लास में क्या करते थे? What did you do in the lower classes? लोअर क्लास में ऐसे करते थे ना, ये वाला ड्राइंग जो क्या करते थे. हाँ, ये हो गया है कि नहीं? So first of all, HCF is nothing but highest common factor. First of all, your common factor is 3. First common factor is 3. Then according to the very definition of HCF, the smallest power of the common factor. What is the smallest power of 3 involved? In all of these, in the prime factorization of 12, 15 and 21, 3 का जो smallest power है वो 3 है, मतलब 3 to the power 1 ही है. In all of these, there is 3 to the power 1, 3 to the power 1, 3 to the power 1. So that is why your HCF is 3 or 3 to the power 1, which is 3 only. That is why this word is used here, highest common factor, meaning the smallest power of the common factor involved in the prime factorization of these 3 numbers. Similarly, if you calculate the LCM of 12, 15 and 21. Now what was the very definition of, break, yeah, break. So in the very definition of LCM, what was the very definition of LCM? If you see, so in the very definition of LCM, what is given? The product of the greatest power of each prime factor involved in the numbers. First of all, in order to see what is the LCM, you just see. अरे ये तो गायब हो गया, अभी अभी तो लिखे थे. Hello. Is the voice not coming? Voice is coming too. Voice नहीं आ रहा है क्या? voice has come, right? Okay, 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 okay. जस्ट अभी अभी इसका इसका लिखे थे, पता नहीं कहाँ गायब हो गया। चलो कोई बात नहीं। Now here I am again doing, you are told to find the H7 LCM for 12. 12 I can write as 2 into 2 into 3. 15 I can write as 5 into 3. 21 I can write as 7 into 3. So therefore your HCF of 12, 15 and 21. If you see, the only common factor involved in the three numbers is 3. So by definition of HCF, your common factor is 3 and 3 का जो सबसे जो कॉमन फैक्टर है उसका स्मॉलेस्ट पावर, अभी 3 का स्मॉलेस्ट पावर तो यही है इन तीनों में, तो दैट इज द HCF and LCM. In order to calculate the LCM 12, 15 और 21 का LCM कैलकुलेट करने के लिए इन तीनों के प्राइम फैक्टराइजेशन में, इन द प्राइम फैक्टराइजेशन इन्वॉल्व इन द थ्री नंबर्स 12, 15 और 21 के प्राइम फैक्टराइजेशन में जो जो प्राइम नंबर इन्वॉल्व है, द हाईएस्ट पावर, the greatest power of all the prime factors involved. If you see, what are the prime factors involved in all these numbers? We have 2 here, then we have 3, then we have 5, then we have 7. In the prime factorization of all these three numbers, what is the highest power of 2? If you see, 2 I can write as, this is 2 into 2 na, so I can write as 2 square into 3. Yes or no? I can write this as 2 square into 3. Correct? Similarly, so here, what is the highest power of 2? 2 square. What is the highest power of 3 in all of these numbers? 3 only. So nothing else. What is the highest power of 5 in all of this prime factorization? 5 only. What is the highest power of 7 in the prime factorization of all the three numbers? 7 only. So therefore your LCM is this. Meaning 2 square matlab 4 into 3 into 5 into 7. Which will come out to, I think around 420. So that is the HCF and LCM. Hope it is clear. Okay. Similarly, you can go on to finding these numbers. Okay. Let us do one more question. Okay. Now we do this question. See, all of these are NCERT questions only, nothing else. सारे के सारे NCERT के question है. We are doing exercise 1.1. See what is given. We are given that HCF of 306 and 657 is equals to 9. We are told to find LCM of 306 and 657 equals to कितना होगा. अभी यहाँ पे here will not go on. सर रिप्लाई दीजिए, किसका रिप्लाई दे भाई. हाँ क्लास 9 सेवा है तो क्लास 9 सेवा, क्लास 9 का सेवा का कोर्स, फुल कोर्स is available on our X school app. अभी बैच स्टार्ट हो गया है. The batch has started. Okay, I will be the teacher only there. I will be teaching class 9. So वहाँ पे the batches are forming. So you can enroll there. Okay, simply download the X school app. You will get all the information there. Okay, it is clear. For class 9 also there, class 10 also. Class 9 and 10 I am only the educator. So if you want, you can go on and see all the information there. Okay, अभी यहाँ पे बुक का पीडीएफ, सर बुक का पीडीएफ अभी सेवा वाले दिया नहीं है, कहाँ से दे तुमको. द पीडीएफ ऑफ द बुक इज नॉट अवेलेबल ऑन द सेवा वेबसाइट. सेवा वेबसाइट में अवेलेबल ही नहीं है. पहली बात तो बुक का, फर्स्ट ऑफ ऑल द बुक इज, पीडीएफ ऑफ द बुक इज नॉट गोइंग टू बी अवेलेबल अप अंटिल से मई और जून. The hard copies are coming. If you are from Guwahati, you go to Panbajar area, you will get the hard copy of the book. They are available, but the stock बहुत जल्दी जल्दी खत्म हो रहा है. ठीक है, तो जितना हो सके जल्दी खरीद लेना. PDF तो नहीं मिलेगा. Even for class 10, even for class 10, for a class 10 book, the PDF of the new book is not available and not uploaded by SEBA till now. But the hard copies are available. If you can buy the book, buy it quickly because the stocks are getting cleared. बहुत जल्दी खत्म हो रहा है. आएगा stock, but it is coming very slowly. Okay. But the पुराना book करके फायदा नहीं होगा. Hailakandi. Okay. Hailakandi, try to see if you are able, if in your nearby shops the book is available, because the PDF is not able. PDF तो नहीं मिलेगा. PDF अभी नहीं मिलेगा. Okay. I will try. Okay. But in our app, I am teaching according to the new book. Although I have the hard copy of the book, but I cannot upload the PDF of the new book. तो सेबा वाला मुझको ही पकड़ेगा कि हम किए काम, PDF तुम डालो, है कि नहीं. मेरा गला पकड़ेगा ऐसे. तो PDF I cannot publicly give it here. If the PDF is readily available and given by SEBA itself, then I can share. Other than that, I cannot share publicly here. ठीक है. Okay. So now, okay. So for this particular question, you are given HCF you are given, LCM you have to calculate. Now for this particular question is where your formula comes in. यहाँ पे आएगा ये formula कि HCF of any two numbers into LCM of any two numbers is equals to the product of the two numbers. This is how the formula we are going to use. We are not going to calculate the HCF of, we are not going to calculate the LCM of 306 and 657 by prime factorization. The question is not testing you, asking you anything regarding that. The question is trying to ask you, checking whether you know this formula or not. Because LCM of, you can go by prime factor, you can prime factorize 306, you will prime factorize 657. That is going to be a very long process. But quickly it can be done. This is simply an MCQ question. If you see, this is simply a okay, this is simply a MCQ question. See, let us see how we can do this. See, by this formula, your HCF of 306 and 657 into LCM of 306 and 657 is nothing but the product of 306 into 657. तो उस हिसाब से HCF तो तुमको already दिया गया है. It is already given. It's already given 9. So this is 9 into LCM of 306 and 657 equals to 306 into 657. This 9 if you bring that side, you will get that the LCM of 306 and 657 is equals to 306 into 657 divided by 9. Now this 9 and 657 is cancelable. 9 1, then this is 7. 9 into 763, then this is 73. Then 306 into 73, 306. You will get as, if you calculate, you will get it as 222338. So just by the application of this formula, this question can be solved in a much quicker manner. Okay, this question can be done in a much quicker and faster way. Okay, so I hope it is clear. Is it clear? Okay, so this is it. This is how we calculate it using this formula. Using this particular formula, we calculated it very easily. Okay, this question keeps on coming for SEBA. This is a highly repeated question. Keeps on coming in HSLC. This particular question keeps on coming in your HSLC exam. Okay, one more question let us do, then I will end the class. Okay, you are told to check whether 6 to the power n can end with the digit 0 or any natural number n, for any natural number n. Okay, okay, here we use this particular thing, that if a number if a number ends with 0, then it is divisible by 5 and 2. Yes or no? If a number, if any number, you take any number in the entire number system, if any number is divisible, if the number ends with 0, then it has to be divisible by 5 and 2. Take 10. 10 is divisible by 5 also. 10 is divisible by 2 also. Take 20. It is divisible by 5 also. 2 also. Take, say, 700. This is divisible by 5 also. 2 also. So any number, if it ends with 0, then it has to be divisible by 5 and 2. So by that logic, in the prime factorization of that particular number, 2 and 5 has to be included as a factor. Okay. So this means that in the prime factorization, 2 and 5 has to be there as its factors. If in the prime factorization we do not have 2 and 5, then that particular number cannot end with the number 0. Now we are asked whether 6 to the power n can end with 0 or not, where n is any natural number. If you see 6 to the power n, I can write as 2 into 3 to the power n. Now this can be distributed as 2 to the power n into 3 to the power n. Now we have prime factorized 6 to the power n. Now in a very prime factorization of 6 to the power n, we have the prime number 2, but I do not have the prime factor 5. No, both have to be present. It is not that 10 is only divisible by 2 and it is not divisible by 5. If a number ends with the digit 0, then it is divisible by 5 and 2, not 5 or 2. It is not that 10 is only divisible by 5, not by 2. ऐसा तो नहीं है कि 20 सिर्फ 2 से डिवाइड होता है, 5 से नहीं होता है. अगर कोई नंबर 0 से खत्म होता है तो वो 5 और 2 से दोनों से डिविजिबल होना ही पड़ेगा. अगर दोनों से डिविजिबल है तो उस नंबर के प्राइम फैक्टराइजेशन में 2 और 5 को डेफिनेटली होना पड़ेगा. लेकिन 6 टू द पावर n के प्राइम फैक्टराइजेशन में 5 है कहाँ? 5 है, 5 तो मिसिंग है, 5 है ही नहीं, 5 है ही नहीं. So by that particular logic only, now we can say that since 5 is missing, in the prime factorization of 6 to the power n, so I can say that 6 to the power n cannot end with 0. चाहे n का वैल्यू कितना भी हो जाए, चाहे वो 6 to the power 99999 ही क्यों ना हो जाए, फिर भी 0 से end नहीं करेगा. That is the power of logic. Okay, that is the power of logic and that is the very power of understanding the very behavior of numbers. है कि नहीं? चाहे n का वैल्यू कितना भी बड़ा हो जाए, we can predict कि वो 0 से n नहीं हो सकता, because we apply the very simple logic. है कि नहीं? ऐसा तो कुछ है नहीं कि बहुत बड़ा कुछ मैथमेटिक्स लगा दिया. सिंपल लॉजिक है. अगर कोई नंबर 0 से खत्म होता है तो वो 5 और 2 से डिवाइड होना ही पड़ेगा. अगर वो 5, ऐसा तो नहीं कि 10 सिर्फ 5 से डिवाइड होता है, 2 से नहीं होता है, 20 सिर्फ 2 से डिवाइड होता है, 10 से नहीं होता है, दोनों से डिवाइड होता है कि नहीं? सो एनी नंबर विद ends with a digit 0, it has to be divisible by 5 and 2, and those 5 and 2 has to be included in the prime factorization of that particular number. और अगर 5 यहाँ पे 2 है 5 है नहीं, दोनों को होना पड़ेगा। तुम अगर ले लो, अगर मैं ले लूँ 10 to the power n, this I can write as 2 into 5 to the power n, so this is 2 to the power n into 5 to the power n, so 10 to the power n, so 10 to the power n will end with 0। कितने जीरो से एंड होता है वो बात की बात है, लेकिन जीरो से तो खत्म होगा ही होगा, क्योंकि यहाँ पे 2 भी है 5 भी है, both of them are included in the prime factorization of 10 to the power n, so that is a particular logic we have used here. I hope it is clear. Next, so this is the last question we'll do. We are asked explain why these two particular numbers are composite number. ये दोनों composite number क्यों है वो पूछ रहे हैं। Very easy. See, what are composite numbers? Composite numbers are those numbers which are divisible by more than two factors. पहला वाला को देखते हैं। If you see the first number 7 into 11 into 13 plus 13, this I can write as, अगर ध्यान से देखो यहाँ से मैं 13 कॉमन ले सकता हूँ, so I can write this as 13, यहाँ से 13 कॉमन लिया तो 7 into 11 into 1 प्लस 1, यहाँ से 13 कॉमन गया, यहाँ से 13 कॉमन गया, यहाँ पे बीच में प्लस है, ध्यान देने वाली बात है। तो दिस इज 13, 7 into 11 77 plus 1, yes, and I got this as 13 into 78, 13 into 78, okay. Then again, if you recall, 78 is nothing but 13 into 6, 13 into 6 into 1 simply लिख दिया, and 6 can be written, so this is 13 into 13 into 6 can be written as 2 into 3, so 2 into 3 into 1, yes. Okay, so if you see this particular number after we divided it, हमको और कुछ फैक्टर्स मिल गए जो यहाँ पे पहले थे नहीं, जैसे कि यहाँ पे 7 था, 11 था, 13 था, but we got 2 also, 3 also, so we got numbers other than the numbers involved, so therefore it is a composite number, है कि नहीं? You can write since 2, 3 are also its factors, so therefore 7 into 11 into 13 plus 13 is a composite number. Okay, so I'll end the class here. There is a lecture 1, then a lecture 2 will be going on. In the lecture 2 we'll be moving on with the exercise and the new concepts on irrationality of numbers. But that part is only going to be available on the X School app. Okay, so for there you can go and see the course details. All the details are available on our app. You can go there, and there I'll be teaching the class 9 and 10 maths, so you can go there. So with this I end the video. I hope you have a safe weekend, enjoyable weekend. Enjoy it, because right after this weekend throughout the Assam classes are going to start. Okay, so happy weekend, happy Sunday.